So let me go over question one again. So the question one is saying how many people strongly agree men make better presidents than women? Now, the men make better presidents than women is a variable in the data. So if you come to the data here, you see you have to look for it. Men make better presidents than women. Good. So this is it. You have to look for it. Men make better presidents than women. A trick for you to be able to determine the variable as in when what is and what you can use the find. So when you click on the find on the search, you just type in what you are looking for. Men make better presidents than women. Then you click OK. It will automatically send you to where that variable is. Okay. So now let's go back to the question. The question was how many people strongly agree men make better presidents than women? So the question is asking us that in the whole data set, how many people say that they strongly agree that men make better presidents than women? So in order to find that out, you go to analyze, descriptive statistics, and then frequencies. Analyze descriptive statistics and then frequencies. Then click on frequencies. Once we click on frequencies, you can drag men make better presidents than women variable inside here. And then we make sure that we tick the frequency tables, display frequency tables, then we click OK. Immediately we click OK, we are going to get this variable table here. We are going to get this variable table here. Good. We are going to get this variable table here. So you see, this gives a summary of the entire population. So the entire population is 172. And out of that 172, 28 people strongly agree. Please, if you understand, say you understand so that I'll know that you are with me. Okay, let's move on. So now the second question is, before we go to question 2, I was saying that they can say how many people, how many males strongly agree men make better presidents than women. So instead of saying how many people, they can say how many males strongly agree men make better presidents than women. And I was saying that in order to find that, it's also very simple. We'll just come to our data set. Then we can tell SPSS that because in the first one, we join everybody together to find the total number of people who strongly agree as 28. We can tell SPSS to separate the males and females or to split the males and females into groups and then find their responses for that one too. So in order for us to do that, we have to come to split file. And this is the icon. You have to click on it, split file. Once you click on split file, we'll choose organize output by groups. Organize output by groups. Then we put gender there because they say how many females, right? So we want to split the population into males and females. So we'll put gender there. Then we click OK. So immediately we click OK, the system will automatically split the files into males and females. So we don't have to worry about that. Then we just come and run our analysis again. Descriptive statistics, frequencies, and then we run our analysis again. When we run our analysis again, we are going to get the output data coming as gender and then male, gender male and then gender female. So it has split the responses for both males and females for us to do what? To see. Then we can answer the question, how many females agree? 3. Now, depending on the version, some people might not have this icon split file here. So in order to find this icon, all you have to do is you come to data, then you scroll down to split file, so it's here. So this is a shortcut, but depending on your version, you might not have this one here. So you can find it in data and then split file. Okay, that's good. So you can continue. Only 3 people are in the meeting. Or 15 participants. Oh, okay, that's good. That's good. That's good. But we are only 3 people. So please, if you understand or if you have any question, just unmute yourself and then speak. Okay. So let's go to the next question. Question 2. It says, what is the percentage of males in the study? What is the percentage of males in the study? So, in order to find the percentage of males in a study, it is also very, very, very simple. But before I go and continue and answer that question, please note that after you have split file, after you have done the split file command, any other statistic that you are going to run is going to do what? It's going to split file for any other thing. So immediately you finish using your split file to find your answer for that question, you have to come back and then reset it. So reset, then click OK, so that it will turn the split file off. If you don't reset it and you run another analysis, it will separate it into males and females. So maybe they might be asking for the total population, but you'll be getting males and females instead of the total. So immediately you are done with the split file, please turn it off. And how do you turn it off? You just come to the split file and then you click on reset to turn the split file off. See, split file off. Good. So now let's answer the next question. The next question, what's the percentage of males in the study? Now, in order to find the percentage of males in the study, we have to run a frequency for the male category, for the gender category. We have to run a frequency for the gender category. So this is the gender category, right? We have to run a frequency for it. So how do we do that? We will come to analyze, descriptive statistics, then we come to frequencies. So I'll click on reset to move the male from there and then put gender inside. And then they are asking us that you should find the percentage, right? So make sure you tick the frequency tables and click what? OK. Good. So when we click OK, we see here. Let me put this down. Good. So after we click OK, we have our frequencies here. So the total number of people in the population is 172. This is a summary, and this is the gender distribution. And the question was asking how many, what is the percentage of males in the study? So we come to our valid percent. Then we'll come to males. So their intersection, that is what? 51.7. We put in 51.7%. Very simple, very, very easy. Please, do you have any questions? Okay, no questions. Good. So now let's come to the third question. The third question is saying, what is the homoglobinol value of the weight? What is the homoglobinol value of the weight? So, in order to solve this question, we'll go back to our data set. We come to our data set here. We look for weight. So, we look for weight, and then we go to so the question is, what's the homoglobinol value, right? So we go to analyze, then we come to descriptive statistics, then we come to explore. Then once you go to explore, you go to plots and make sure that the normality test plot has been ticked. Make sure that the normality test plot has been ticked. Then click on OK. When you finish, then in our dependent list, we'll put weight there. We'll put weight there in our dependent list. We'll put weight there. When you finish, we click OK. So SPSS is going to automatically generate everything for us, and then we come and we get the normality test with plots here. So this is a summary. This is a descriptive of the weight, so we can find the mean, but that's not what the question is asking. It's asking for the homoglobinol test value. And where will we get that? That is this one. So when you come to the test of normality, the homoglobinol section, you see statistic. So under the statistics, we see 0.127. So that becomes the homoglobinol test value. Homoglobinol test value. Very simple, very easy. Then we type it inside. So on to the next question. It said,
can you please add the homoglobinol value again?
Sorry?
Can you please go over that again?
Okay. So somebody is saying we should go over the homoglobinol value of weight again. That's question 3. So to find the homoglobinol value of the weight, you come to your data set. Then you look for weight. So this is your weight, right? So once you have seen your weight, you come to analyze. From analyze, you go to descriptive statistics. From descriptive statistics, you go to explore. Explore. Then click on explore. If you click on explore, this window will open. Then in the dependent list here, you move weight into it. So in order to move weight into it, you have to look for it from this box. So this is my weight. Then I click this arrow and move it into the dependent list. When I move into the dependent list, then I'll go to plots. Plots. Then I click on plots. Then when I come to plots, I make sure that normality plots with test is ticked. I have to make sure that normality plots with test is ticked. So once it's ticked, I just click continue. Then after I'm done, I just click on OK. When I click on OK, SPSS will automatically give me the answer. And I was saying that this is the answer for what we have, the command we have issued. But this is a summary of everything. This is the descriptives that's descriptives of the weight that SPSS has generated for us. But that's not what the question is asking. The question is asking that what is the homoglobinol test value, right? So you come to the normality test of, you come to the test of normality, sorry. Then in the homoglosphenols section, you come to the statistic. Then under the statistic, the value there will be our answer. So the value becomes 0.127. Very simple, very easy. Can I continue? Okay, I'm continuing. The next question, question 4. He said, what is the height? No, he said, is the height a parametric distribution? Is the height a parametric distribution? If not, specify the type of skewness. If not, specify the type of skewness. So he said, is the height a parametric distribution? If not, specify the type of skewness. So here, how will we be able to answer this? So for us to be able to answer whether the height is a parametric distribution or not, we have to run a normality test with plots for height. So we'll come back to our data set. Then we come and look for height. So they are asking us if height is parametric or not. So we come to our data set and come to height. And in order for us to know whether it is parametric or not, we have to run a normality test. So to run a normality test, you come to analyze, then go to descriptive statistics, then go to explore, then click on explore. So I'm resetting this window. So when I come to explore, in this tab, I'll look for height. If you want to look for height, when you type H, it will just move you to the next H. So you just type H. So that is my height. So I'll move the height into my dependent list. Then I'll come to plots. Then I'll make sure that I take normality test with plots. I make sure I take normality test with plots. Then I click on continue. When I'm finished, then I click OK. So to SPSS will automatically run the test for normality for me. So this is the test for normality. This time, they are not asking us that what is the homoglosphenols test value. They are asking us what is, they are asking us if height is parametric or not, right? So in order for us to know if height is parametric or not, we have to look at the significant value here, right? You have to look at the significant value here. And what is the value? It is what? 0.001. 0.001. Then we ask ourselves from our previous lesson, we said that if when you are testing for normality, in our previous discussion, we said that when you are testing for normality, when the p-value is greater than 0.05, then it means that what? It is normally distributed. So this one is a rule that you have to know, right? We said when the p-value is greater than 0.05, then it is normally distributed. And if it is normally distributed, then it is automatically what? Parametric. So the opposite is true. So from our data, our p-value is what? 0.001. So we'll ask ourselves, is 0.001 greater than 0.05 or less than 0.05? It is less. So because it is less, it means that the data is what? Not normally distributed. It means that the data is not normally distributed. And if the data is not normally distributed, then it means that what? It is non-parametric. If the data is not normally distributed, then it means that what? It is non-parametric. Good. So if it is non-parametric, it answers our question, which is the height a parametric distribution? So the answer will be no, because it is what? Not normally distributed. So if not, specify the type of skewness. If not, specify the type of skewness. So how will you solve this question? Let me come back to this, my types of data. Remember, I said if it is rightly skewed, you look at this tail here, where the tail is pointing to. So if this tail, so if this tail is pointing to your right, then it means that it is rightly skewed. If it is pointing to your left, then it means that it is what? It is left skewed, right? So we'll come back to our data. Look at our data here. So this is the curve, right? This is the curve. And where is the tail? The tail is pointing to the left. The tail is the long side. The tail is pointing to what? The left. And it means that the data is what? Left skew. So that answers our question. It means that the data is left skew. That answers our question. You can also determine the skewness from a skewness value. So if you look at the descriptives here, you see skewness there. If the skewness is less than 0, then it is what? Left skewed. If it is greater than 0, then it is right skewed. So you see our skewness value is negative 0.647. It means that it is what? Left skewed, because it's less than 0. So it is left skewed. So our skewness value agrees with the QQ plot here. So it's the same thing. Okay, to the next question. We say, how many males aged 22 to 25 are anemic? So this question is a very tricky question.
5.
Yeah. Somebody is asking.
Number 5. Number 5. You skipped number 5.
Please speak up. I can't hear.
You skipped number 5.
Sorry. I'll skip number 5. Okay, so let's do number 5 first before we continue. Oh. So number 5. Number 5 says that what percentage of people are single? What percentage of people are single? Now, the key word is percentage. Where can we get percentage? We have learned this already. Percentage can be obtained from what? Frequencies. Good. And they are saying what percentage of what? People. So they are saying the entire distribution, right? Good. And they are saying what percentage of people are what? Single. So here they are very specific. They are saying what percentage of people are single. So we'll come to our data set and look for marital status. We look for marital status. That is here. Good. We look for marital status, which is here, and then they are saying what percentage of these people are single. So in order to find the percentage of people who are single, we just have to analyze the security statistics, frequencies, and then we click frequencies. So I'll reset this and put marital status there. In order to find marital status, you can just click M on your keyboard. It will move to the next M. So that's next M. Then maybe better. So good, marital status. So once we find marital status, we just move it to the variable there and make sure that we have ticked display frequency tables. Then we click OK. So the question said that what is the percentage of people who are what single? So we just count. So this is the frequency output that SPSS generated for us. This is a summary, and then this is a more detailed of the analysis. So we can see our marital status here being described in terms of frequencies and percentages. So we see single people here. The total number of single people is what? 165. 165. And then the other people who are cohabiting, those who are cohabiting school, they are what? 7. So you can see that the single people are doing what? They are suffering, but relative people are suffering. So the question is saying, what is the percentage of people who are single? So the percentage of people who are single, we have to come to the valid percent, and that is what? 95.9. So the percentage of people who are single is 95.9%. But please note, in your exams, they might ask you to convert it into 1 decimal place or 2 decimal places. So depending on the type of question, then you do that conversion. Okay. Let's continue. Number 6. How many males aged 22 to 25 are anemic? How many males aged 22 to 25 are anemic? So this is a very specific question. They are asking you that how many males, which are between the ages of 22 to 25, are anemic. So how will we answer this question? Let's go to our data set. In order to answer this question, because they are being specific and they are asking us that how many males, so first we have to tell SPSS to split file and then solve for only males and then females. So you solve for males and females what separate. So click split file. Then we'll say organize output by groups. Then we'll put what? Gender there. Then when you put gender there, we click OK. So you see cases sorted by gender and split file separate by gender. So now whatever analysis that we run is going to give us males separately and females separate. So now the question is, how many males aged 22 to 25 are what? Are anemic. So we can come to our data set again, and then we look for our age group. Where's our age group? We look for our age group. I'm not that age group yours. Okay, this is the age group. So our age group here, and then the anemic people also.